Hi everyone, welcome to this episode of Keipert Labs. In today's video we're going to be discussing solutions. So we're going to firstly define what do we mean by a solution, give some examples of what some solutions we encounter in everyday life, break down some of the terminology in terms of solvents and solutes as things related to solutions, look at the process of dissolving. We're going to define what it means for something to be soluble or insoluble, and also look at, lastly, the concept of saturated solutions. So firstly, what is a solution? So we've been talking about mixtures. A solution is a particular type of mixture. Specifically, a solution is a homogeneous mixture. Now, in thinking about this, it would be thinking, okay, well, some homogeneous mixtures solutions, or are some solutions homogeneous, or whatever. The reality is that all homogeneous mixtures can be defined as solutions. So all homogeneous mixtures are solutions. So where we've got one substance that its particles are separated and it's dissolved in the other. Okay, but this thing, it can be any state of matter. So for example, we've got a solid that dissolves or combines with a liquid to make this solution. We also have two liquids that combine to make a solution as well. You can get a liquid in a gas, or a gas in a liquid, which is a solution. Okay, you can get gases and solids and all of these things as well. So we can start to get more specific and break down some of those kind of terms. So some of the examples of solutions that we encounter in everyday life: seawater. So as a solution of all sorts of salts like sodium chloride in water. We have tea. We have copper sulfate, something that we commonly look at in a science lab. Not in everyday life, but it's a solution. Saline, like you might have in a drip, if you're on an IV drip, if you're in hospital, is a solution. It's a salt solution, or salt and sugar and other sorts of things as well. And also honey is a solution. So you can see that it's not all about things being really runny. So honey is a solution that's very thick. We say, in scientific terms, we say it's viscous. All of these are everyday examples of solutions. So how do we define? Let's think about the parts that come together to make up a solution. We have a solute and a solvent that combine together to make a solution. Okay, so the solute refers to the substance being dissolved. It is the lesser substance, the one there is fewer particles of relative to the other. The solvent is the substance, typically the liquid, the solute is being dissolved in. So it might be water, it might be ethanol, like that is alcohol or methylated spirits. It might be all sorts of other things. It might be oil, okay? But it also doesn't have to be a liquid. And I realize it says liquids here, but thinking back to what we just said, that it can be any state of matter, is that it can be more than just a liquid, but it's also the substance that there is more of. Okay, so there are more water particles than there are solute particles. And so now we're going to think, all right, what does it mean for something to dissolve? Okay, we've said that a solute dissolves in the solvent. And so here we've kind of got a diagram that shows a bit of that stage of that process. So we start with some solute particles, the orange ones that are all stuck together. And we have lots and lots of blue solvent particles. Obviously not all of them are represented here, but just to show you a bit of that process. And then what happens is that the solute particles, the orange particles, gradually start to separate from each other. Typically it's that the solvent particles start to kind of pull them out, and they kind of separate and surround them. And that those orange particles gradually spread their way through evenly through our solution, so that we say the technical term is evenly dispersed. It is completely spread out throughout. That there's no bit at the top or the bottom or at the sides that is more or less orange particles than anywhere else. It's all completely uniform. So now it's two words that we use to describe whether something will dissolve in something else or not. And we use the word soluble, which refers to something that can dissolve in the solvent. So if it is soluble in water, it will dissolve in water. Versus insoluble means that something that it can't dissolve in the solvent. Okay, so we've got a blue transparent solution here. So all those blue particles have evenly spread throughout. You can see right through it. Obviously the photo is a bit blurry, so that's not perfect to see for the contrast. But insoluble, you can see the difference, that we've got lots of these yellow particles that have settled to the bottom. It's very cloudy in the watery, the solvent part. Okay, it hasn't dissolved. But also, when we're thinking about solutes, we can also be thinking about liquids. So for example, oil and water. So we can see that oil and water don't mix, or we might say that oil is not soluble, is insoluble in water, or that water is insoluble in oil. But it's actually a bit more correct for us to use two different terms. We say miscible, so M-I-S-C, miscible, or immiscible is more the term that we use for liquids. Do the liquids mix with each other or do they not? Okay, it's a bit more of the technical term that we'd use. So oil is immiscible with water and water is immiscible with oil, whereas water and alcohol are miscible. They will mix together. Okay, so it's the MISC is like in miscellaneous. Okay, so it's not miscible. Just let's get that right from the start. Okay, and so finally we're going to talk about saturated solutions. So let's say we've taken a solution and then we're putting solute into it. We're stirring it in, we're mixing it in. Eventually we find that we reach a practical limit, a point at which no more solute could dissolve in that amount of solvent. So thinking about this example here, we're putting sugar in a cup of tea or a cup of coffee. Now, if you take, and you put 1 teaspoon of sugar in, you stir it in, it'll dissolve. 2 teaspoons will dissolve. 3 teaspoons, 4 teaspoons, 5 teaspoons, 6 teaspoons, 10 teaspoons, 20 teaspoons, 50 teaspoons. Okay, now we're getting a bit absurd. Nobody would have their coffee like that. It'd stand up on its own. But the idea being that you do get to a limit at which you can't dissolve any more of that solute. You couldn't put any more sugar in that cup of tea. And the way that we notice that is that the extra solute, the bit more that we add, remains undissolved and settles to the bottom typically, because it's usually still in big particles that sink. Okay, so that it remains undissolved at the bottom. So you could keep adding more and more sugar and you're just increasing the amount of sugar particles that settle to the bottom. Now you might have noticed this in a cup of tea or a cup of coffee as well. Not that you're probably old enough to drink coffee, but you might have seen this, that often if it's not mixed very well, if it hasn't had a chance to dissolve, that the bottom bit of a cup of tea or a cup of coffee is much sweeter because those bits of sugar are still sitting at the bottom. And unless you give it a really good stir and you keep mixing it throughout, that you often end up with this stuff that's not dissolved at the bottom. Okay, so we defined what is a solution. That is, it's a homogeneous mixture. We looked at some examples like tea and honey, saline and seawater as examples of solutions in everyday life. We broke a solution down in terms of solvent, the liquid doing the dissolving, and solute, the substance being dissolved, the smaller amount of stuff. We've said that we looked at this process of dissolving and what does it mean for a solute to dissolve in a solvent. And then we looked at whether defining things as soluble or insoluble, as well as then the concept of a saturated solution. So one of those solutions where we've reached the maximum amount of solute that will dissolve. Thanks very much for watching. Bye for now.